Okay, we're taking a look at problem 26.21. We're actually going to, this thing is just sort of, because of the way I had to write it out or cut it out, I don't have that anymore. So we're trying to find in the circuit that's shown there, we're trying to find the current in resistor R, and we're trying to find the resistance there, and we're trying to find the unknown EMF, and we're trying to find out if we break the circuit at point X, what is the current in resistor R. So first we have to find out that current. You can see the batteries are all turned all kinds of ways. So there are three possible loops. There is the top loop here. There is the bottom loop. And there's a loop that goes all the way around. So those are all of our choices. But first we got to define what our currents are. I'm going to call one current the current that goes this way. I don't even know if it is a current that goes this way. Looks like I already have two currents. They actually already define them for me. So I don't even really need to do that. Originally my thought was to define the currents, but it's not necessary because they tell me what two of the currents are. They tell me that the current across this resistor is 4 amps, and they tell me the current across this resistor is 6 amps. So by the junction rule, you can see that I have 6 going this way, and I have 4 going that way. Well, again, that means that I'm going to have upwards is going to be 2 amps. Okay. And again, I'm going to follow my loops around and figure out all the stuff I don't know. So I'm going to start with this outer loop, the one that I had around this way. So I'm going to start, and I'm going to go the outer loop, and I'm going to go counterclockwise around it, basically because I want to make the battery positive. So I'm going to start 28 volts minus the voltage of the voltage across the resistor, the 3 ohm resistor, the one down here. And I'm going to call that, okay, I'm going to call that 3 ohms times 6 amps. The next one I go to is this resistor up here. Okay. And that's going to be R times the current, which we figured out was going to be 2 amps, and all that's going to equal 0. My direction of my loop was counterclockwise, and it always matched the current, so they're always going to be like that. So I have 28 minus 18 minus R times 2 amps equals 0. So I end up with 10 amps, or sorry, 10 volts equals R times 2 amps. I end up with R equals 10 volts divided by 2 amps gives me 5 ohms. Okay, so that's the first part of my problem. For part B, they want me to find out what actually I found part A and B already. I found the current in resistance R, that was the 2 amps that we found up top, and part B was the resistance R. So my next step is part C, to find this unknown EMF over here. Okay. And it's a lot easier to find now that I have everything else in the circuit. Okay. So I'm going to make a loop of just this loop down here. So I'm going to make a loop of the bottom. And I'm going to make it counterclockwise because I want to match those directions of the current if I can. So I'm going to have E minus 3 ohms times 6 amps. I'm at the bottom now. Now I'm back up at the top, minus 6 ohms times 4 amps. And now I'm back at the battery, at the other end of the battery, so it's going to equal 0. So I have E minus 18 volts minus 24 volts equals 0. That's going to make the voltage of that middle unknown battery 42 volts. Part D of this problem says, if the circuit's broken at point X, what is the current through resistor R? Well, remember we already found out that R was 5 ohms. We found that in another part of the problem. So, and again, it's going to be broken here. So that means that we're not going to have anything going through that. That's not going to make any contributions either. It's only going to be the outside. So I'm going to make a loop of that. Okay. It also means that my current, that 4 ohm or 4 amp current, isn't going to exist anymore. Okay. So, and I don't even know what this current is. I can't use it anymore. Okay. So I'm going to make my loop 28 volts. Okay. Now I'm going to go back to the one at the bottom, minus 3 ohms times I, because I don't know what the current is anymore, minus 5 ohms, I should put those in parentheses, times I. These are in series now because there's only one loop in the whole circuit, equals 0. Okay. So it's going to be 28 volts minus 8 ohms times I. So the current is just going to be 28 volts divided by 8 ohms. And that should be, if I remember right, but I'm going to check it to be sure. Yep, it is 3.5 amps. So I got 3.5 amps for the current for that.